Dear students, I am Dr. Ashok Kumar Saini, Associate Professor in Mathematics in BLJS College, Tosham. Today I will deliver lecture on Dynamics Mathematics paper 3rd for the BA BSc 3rd year 6th sem students on the topic. This is wait. Impulse on the topic some examples which remains on principle of conservation of energy. Mass m is attached to one end of an elastic string of natural length a, the other end being tied to a peg. Initially m is held near the peg and projected with a velocity v vertically downwards. The particle moves all along a straight line so that the depth h below the peg of mass m when it is at rest is given by the equation v square plus 2gh equal lambda time by ma h minus a का whole square, where lambda is the modulus of elasticity of the string. The figure here is, this is the figure. O a point OA equal to A, total length OB equal to H, and AB equal to H minus A. Let OA equal to A be the natural length of the string. Let B be the lowest point reached by the mass m when projected downward from O. Take B as the position of zero potential energy. This is the lowest point. B is the lowest point. Take it as the take B as the position of zero potential energy. Therefore OB equal to H and BA equal to H minus A. At O, kinetic energy equal to half mv square and potential energy equal to potential energy due to gravity minus potential energy due to tension is equal to mg into h minus half tension at A plus tension at B. Potential energy due to gravity is mgh and potential energy due to tension, this also we have done, is half mean of the tension at A and plus tension at B minus half tension at A plus tension at B into extension. We have already done this expression in elastic strings, is equal to mgh minus half tension at A. A is the middle point, is point in at any OA equal to A, mgh minus half 0, tension at A is 0, lambda is modulus of elasticity, h minus a divided by a into h minus a, taking common h minus a, is equal to mgh minus half lambda by a b minus a का whole square, sum of kinetic energy and potential energy at O is equal to 1 by 2 mb square plus mgh minus half lambda by a h minus a का whole square, sum of kinetic energy and potential energy at O. O is point, see the figure again. O is the highest point. Sum of kinetic and energy and potential energy at O is equal to half mb square plus mgh minus half lambda by a h minus a का whole square. At B point kinetic energy is 0, lowest point, and also potential energy is 0. Therefore sum of kinetic energy and potential energy equal to 0. Therefore from 1 and 2, this is here 2, this is here 1, half mb square plus mgh is equal to minus half lambda by a h minus a whole square equal to 0. Therefore v square plus 2gh cancelling is equal to lambda time lambda divided by ma into h minus a whole square, which we want to prove, disprove when it is at rest is given by the equation. We study again this problem. A mass m is attached to one end of an elastic string of natural length a, the other end being tied to a peg. One end is fixed and the other end is attached a mass m. Initially m is held near the peg. M mass is held near the fixed point and projected with a velocity v vertically downward, and after that we project the mass with velocity v vertically downward. If the particle moves all along a straight line, show that the depth h below the peg of m when it is at rest is given by the equation v square plus 2gh equal to lambda divided by m में h minus a का whole square. यानी at a b equal to h minus a, total is h, ob equal to h. Let OA equal to a be the natural length of the string. OA natural length is of the string. Let B be the lowest point reached by the mass m when projected downward. Let B be the lowest point reached by the mass m when projected downwards from O. This again see the figure. जब O से प्रोजेक्टेड डाउनवर्ड करते हैं तो B तक जाता मास. टेक B एज द पोजीशन ऑफ जीरो पोटेंशियल एनर्जी. इससे आगे नहीं जाता, इसलिए इसको we take it zero potential energy. Take B as the position of zero potential energy. Therefore OB is equal to H and BA equal to H minus A. At O ओ पे क्या है, कनेटिक एनर्जी ड्यू टू हाइट हाफ एम बी स्क्वायर है, एंड पोटेंशियल एनर्जी ओ पे पोटेंशियल एनर्जी ड्यू टू ग्रेविटी माइनस पोटेंशियल एनर्जी ड्यू टू टेंशन। दो कारणों से पोटेंशियल एनर्जी है ओ पे। पोटेंशियल एनर्जी ड्यू टू ग्रेविटी, दिस इज mgh, according to formula this is mgh, minus potential energy due to tension. Tension this we have studied already in elastic strings, minus half tension at a plus tension at b into extension. We have studied this half mean of tension into extension. Now putting the value of this tension at a is equal to mgh minus half tension at a, this is a point, a पे टेंशन 0 है, एंड टेंशन एट बी, बी पे टेंशन है lambda. Lambda is tension is proportional to extension divided by the original length is equal to lambda Young's modulus of elasticity into extension divided by the natural length. This tension at B is given lambda h minus a divided, this is extension and a is original length, and extension is h minus a guna extension. This is the relationship. Now is further simplification of this is equal to mgh minus half lambda by a h minus a का whole square. Therefore sum of kinetic energy and potential energy at O पे, पहले ए पे लिया अब ओ पे आ रही है, पहले ए पे लिखा रहा है दिस इज, फिर ओ पे निकाल रहा है। तो सम ऑफ किनेटिक एंड पोटेंशियल एनर्जी एट ओ इज इक्वल टू हाफ एम बी स्क्वायर प्लस एम जी एच ओ माइनस हाफ lambda by a h minus a का whole square. This above, therefore above relation sum of kinetic energy and potential energy is at O half mb square और ऐड किया ऊपर वाले एक्सप्रेशन में, ऊपर वाले एक्सप्रेशन में एम जी एच ऊपर किनेटिक एनर्जी थी, इसमें हाफ एम बी स्क्वायर ऐड कर दिया प्लस एम जी एच ये आ गया माइनस हाफ लेमडा बाई ए एच माइनस ए का होल स्क्वायर। एट बी, बी पॉइंट पे काइनेटिक एनर्जी 0 है, लोएस्ट पॉइंट पे ग्राउंड पे काइनेटिक एनर्जी 0 है, एंड आल्सो पोटेंशियल एनर्जी इज आल्सो 0. Therefore sum of kinetic energy and potential energy is equal to 0. From first and this is second expression, this above is first expression. From first and second, sum of kinetic and potential is left hand side is 0. We have find out from second, put in 1. So from 1 and 2 we get half mb square minus mgh minus half lambda by h minus a का whole square equal to 0. Therefore after simplification we get b square plus 2gh is equal to lambda by ma h minus a का whole square, which we want to prove. Okay, now we will do one more example if time permit us. A ring of mass m slides on a smooth vertical rod. Attached to the ring is a light string passing over a smooth peg distant a from the rod, and at other end of the string is a mass m greater than small m. The ring is held at on a level with the peg and released show that it first comes to rest after falling a distance 2m capital M a divided by m square minus a square. Again we study this relation. A ring of mass m. This we make this figure. एक रिंग है, रिंग जिसका मास m है, स्लाइड्स ऑन ए स्मूथ वर्टिकल रोड ए पी, उस पर स्लाइड कर रहा है. अटैच्ड टू द रिंग इज ए लाइट स्ट्रिंग पासिंग ओवर ए स्मूथ पैग डिस्टेंट ए. ये क्या है, एक पैग है ए टू क्यू, ए ओ है आई थिंक, ये ए डिस्टेंट पे है, डिस्टेंट ए फ्रॉम रोड से एक पैग है जो ए दूरी पे है, एंड एट द अदर एंड ऑफ द स्ट्रिंग इज ए मास कैपिटल एम ग्रेटर देन स्मॉल एम. ये मास है कैपिटल एम जो ग्रेटर है स्मॉल एम से. दिस इज स्मॉल एम. ठीक. The ring is held on a level with peg and released. ये रिलीज करते हैं इसको. Show that it first comes to rest after falling a distance 2m capital M a m square minus small m. Let Q be the peg and AB be the vertical rod. This Q पैग है और ए बी वर्टिकल रोड है. सो डैट ए क्यू इज इक्वल टू ए. इनिशियली द रिंग इज एट ए पे है इनिशियली. व्हेन इट इज रिलीज्ड इट विल मूव डाउन अलोंग द रोड अंडर इट्स वेट. ए टू पी जाता है. एट द मास कैपिटल एम मूव्स अप, और मास m है जो ये कैपिटल M है ऊपर जाता है, क्योंकि नीचे जाता है तब मास ऊपर जाएगा बैग से. लेट द रिंग कम्स टू रेस्ट एट पी पॉइंट पे ये रिंग रेस्ट पे आ जाता है. नीचे जा रहा है, ये खींचेगा इस रस्सी को, रेस्ट पे आ जाता है पी पॉइंट पे. तो ए पी लेट मान लेते हैं एक्स है ये. ना पोटेंशियल एनर्जी लॉस्ट बाय द रिंग एम जी एच होता है ये, क्योंकि एक्स डिस्टेंस पे आ गया तो एम जी एक्स हो गया. द डिस्टेंस थ्रू विच कैपिटल एम मूव्स अप बाय दिस टाइम कितना हो गया ये, पी क्यू माइनस ए क्यू. पी क्यू माइनस ए क्यू. PQ minus AQ, and PQ is your under root A square plus X square. This is y triangle, y Pythagoras theorem. PQ under root A square plus X square minus A. AQ is A. Therefore potential energy gained by capital M is equal to mgh. Here is under root A square plus X square minus A. Since the system starts from rest and finish at rest, start भी रेस्ट से होती है, फिनिश भी रेस्ट से होती है. Therefore by principle of conservation of energy we get mgx equal, both the expressions are equal, is equal to mg under root A square plus X square minus A. On simplification of this we get mx plus ma का होल स्क्वायर इक्वल टू m स्क्वायर a स्क्वायर प्लस x स्क्वायर और m स्क्वायर x स्क्वायर प्लस 2m कैपिटल M a x इक्वल टू m स्क्वायर x स्क्वायर और m स्क्वायर कैपिटल M स्क्वायर माइनस m स्क्वायर x इक्वल टू 2m कैपिटल M a implies x equal to 2m capital M a divided by m square minus a square, which we want to prove. Thank you, students. You can view this lecture online on college website named www.bljscollege.com. Thanks.